you ever wonder, what makes a life-changing history? Right, a solid mission of the visionaries. It was Dr. Anka and his colleagues' mission to accelerate technology development. Through the establishment of Institut Teknologi Sepuluh Nopember, their goodwill has encouraged ITS students to take important roles in both local and global communities, ministers, CEOs, professors, entrepreneurs, and yes, another history maker. These successful alumni were trained in a healthy learning environment that was equipped with various supporting facilities. From vocation to marine technology, all faculties and departments of ITS were formed to be the best place to learn science, technology, and design. 7 faculties and 1 interdisciplinary school. Scientists, Faculty of Science and Data Analytics. MARTech, Faculty of Marine Technology. INSYS, Faculty of Industrial Technology and Systems Engineering. Electex, Faculty of Intelligent Electrical and Informatics Technology. CivPlan, Faculty of Civil, Planning, and Geoengineering. CreaBiz, Faculty of Creative Design and Digital Business. Vocation, Faculty of Vocation. And Interdisciplinary School of Management and Technology. Recognized as one of the top best-ranked institutes doesn't mean the finish line for ITS. To gain greater international recognition, ITS launched International Undergraduate Program. Students can get wider international exposure through 20 study programs they can apply. The chances are also open for professors from all over the world to teach and conduct research at ITS. These opportunities have made international joint research and other international activities successfully performed. Like IUP, students and lecturers from other programs have also contributed to the ITS achievements. Appreciations earned exemplify Institute's excellent performance. But technology and academic excellence is not the only goal of the Institute. Students are guided to apply their knowledge for the welfare of society. Because to note a new life-changing history, technology must advance humanity. ITS, Institut Teknologi Sepuluh Nopember.
G.
R
is S.
Is the IEEE
Geoscience
and Remote Sensing Society.
We work to advance science and technology in the field of geoscience and remote sensing. Our mission is to build a community of researchers and practitioners by means of knowledge sharing and scientifically rigorous dissemination of the latest advancement in remote sensing. The members of our society have skills in all aspects of remote sensing.
Digital beamforming,
machine learning methods for robust data fusion,
micro-remote sensing,
water quality monitoring and mapping,
micro-radiometry and global navigation satellite systems.
There are a lot of different points of view. Sharing the knowledge among the different communities is what makes this society stronger.
GRSS has established 7 technical committees at the moment, and they all cover different technical aspects. The technical committees are really meant for doing the technical outreach to other parts of the research community and industry.
As a society, we want to inform our members and reach different communities via different channels, like, for example, social media, journals, and especially education. We have 3 series of webinars. GSS has a high school and undergrad student outreach program to engage the next generation of remote sensing professionals.
At the moment, we have more than 60 chapters and 20 student branches all over the world. The chapters are our link with local communities, and they facilitate communication with our members.
IEEE GRSS fully supports Distinguished Lecture Program and also supports for workshops, seminars, and SharpNet programs. Our students are actively engaged in different activities, including competitions.
Our chapter is composed by graduate and undergraduate students. The activities comprise workshops, webinars, lectures, short courses, training, and we have humanitarian activities.
I'm part of the San Francisco Bay Area Joint Chapter. This is a chapter that brings together professionals and those in industry. There are so many geospatial things going on in the Bay Area, and the chapter has been a great opportunity to bring all of those communities together.
All the activities by the societies are supported by our volunteers. We have position for everybody who is willing to help.
I'm a GRSS Young Professional Ambassador. My goal is to empower and motivate young professionals around the world.
I'm a GS social media ambassador. We post the latest information about GS every day.
We aim at inspiring technical community to advance remote sensing. Everybody is welcome to join us.
GRSS connects you to a lot of interesting people working on a lot of interesting topics.
Society acts as a platform to provide resources and opportunity for us in advancing our career.
I enjoy being part of such a great society with amazing people to create experiences for people to remember.
Being part of GRSS allows me to be a better researcher and professional, improving my skills and knowledge to do a good job. Come and be part of this great family. Ciao!
Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening to all participants from all over the world. My name is Putri Pratama Ohorela, and it's an honor for me to be a master of ceremony in this very special occasion, virtually held from the 5th floor Research Center building, ITS Campus, Sukolilo, Surabaya. Today's conference will be very interesting for academicians, scholars, and also practitioners to exchange ideas, since the theme is specifically on understanding the recent development and also richest trend in the field of geosciences, electronics, remote sensing technology, and its application in management of city, land, ocean, maritime, and disaster mitigation in this pandemic era. So welcome to the IEEE Asia-Pacific Conference on Geosciences, Electronics, and Remote Sensing Technology 2022. First of all, I'm pleased to welcome His Excellency Rector of ITS, Professor Muhammad Ashari, Honorable Representative of IEEE Joint Aerospace and Electronics System, also Geoscience and Remote Sensing Society Chapter, Dr. Arifin Nugroho, President of IEEE Indonesia Section, Dr. Wahyudi Hasbi, Organizing Committee, Professor Bangun MS, Chair of Indonesia Remote Sensing Society, Dr. Auk Agustan, Chair of OSTEAM Joint Chapter, Dr. Marina Frederick, also honorable speakers, and of course all participants. Before going further to the next agenda, please take a moment for singing our national anthem, Indonesia Raya. So now let me process to the first agenda, and the first agenda will be a report delivered by the organizing committee. So we would like to invite the Honorable Professor Bangun MS, who has already joined us via Zoom, to give the report. So hello, Professor Bangun, can you hear me? So once again, to all participants, we inform you that Professor Bangun has already joined us via Zoom. So maybe the first, we will check for the audio first. Hello, Professor Bangun. Can you hear me? Hello. Okay. Hello, Professor Bangun. Are you there? Can you hear me? Okay, once again, maybe for your information to all participants that Professor Bangun will join us
Recording
after
in
this via
progress.
Zoom. And maybe we're going to check the audio first and also check the connection. And after this, we will hear together the report from the organizing committee, which is Professor Bangun MS, to give the report. Maybe once again I will check the audio. So hello, Professor Bangun. Are you there? Okay. So hello, Professor Bangun. Can you hear me? So maybe we just heard together that Professor Bangun has already on his Zoom. Hello, Professor Bangun. Okay, so now we are connecting with Professor Bangun. So could you please give some greetings maybe for checking the audio first? Hello, Professor Bangun. Good morning. Okay, as we can see together that Professor Bangun has already joined on his Zoom now. And maybe we're trying to check the audio first before straightforward to the report. So, hello, Professor Bangun. Could you please give some greetings to us to make sure that audio is okay? Hello.
Ya, saya kasih ke audiens. Oke, ya bacain.
Oke.
Yuk, pakai ini aja, pakai ini aja.
Okay. So now, hello, Professor Bangun. Can you hear me? Hello? Okay. So, after this, Professor Bangun will give the report. So, is it okay for the connection or the audio? Maybe you try to give some greetings to us to make sure that the audio is okay. Hello? So, Professor Bangun, maybe you try to give a speech by this phone. So by WA. So now we are still connecting by WA. So you try to give the report by WA. Okay, maybe to all participants, we are really sorry maybe for the technical issues that is recently experienced by us. So maybe you can wait for a moment because we're trying to connect with Professor Bangun as soon as possible. Okay, once again to all participants, we kindly extend our apologies because, yeah. Okay. For your information to the honorable ladies and gentlemen, we are really sorry for the very poor connection or even having trouble with the technical mechanism. So we will wait in more or less 5 minutes to solve the problem. Thank you.
G
R
is S
is the IEEE
Geoscience
and Remote Sensing Society.
We work to advance science and technology in the field of geoscience and remote sensing. Our mission is to build a community of researchers and practitioners by means of knowledge sharing and scientifically rigorous dissemination of the latest advancement in remote sensing. The members of our society have skills in all aspects of remote sensing.
Digital beamforming,
machine learning methods for robust data fusion,
micro remote sensing,
water quality monitoring and mapping,
micro radiometry and global navigation satellite systems.
There are a lot of different points of view. Sharing the knowledge among the different communities is what makes this society stronger.
GRSS has established 7 technical committees at the moment, and they all cover different technical aspects. The technical committees are really meant for doing the technical outreach to other parts of the research community and industry.
As a society, we want to inform our members and reach different communities via different channels, like for example social media, journals, and especially education. We have 3 series of webinars. GSS has a high school and undergrad student outreach program to engage the next generation of remote sensing professionals.
At the moment, we have more than 60 chapters and 20 student branches all over the world. The chapters are our link with local communities, and they facilitate communication with our members.
IEEE GRSS fully supports distinguished lecture program and also supports for workshops, seminars, and SharpNet programs. Our students are actively engaged in different activities, including competitions.
Our chapter is composed by graduate and undergraduate students. The activities comprise workshops, webinars, lectures, short courses, training, and we have humanitarian activities.
I'm part of the San Francisco Bay Area Joint Chapter.
So now let me process to the first agenda. And the first agenda will be a report delivered by the organizing committee. So we would like to invite the Honorable Professor Bangun MS, who has already joined us via Zoom. So here we go. Hello, Professor Bangun. Are you there? Is it?
Okay.
So, wait, Prof. Bangun.
Yeah. On behalf of the local organization committee, I would like to welcome you all to the 2022 IEEE Asia-Pacific Conference on Geoscience, Electronic and Remote Sensing Technology, which will take place at the Research Center Building, Institut Teknologi Sepuluh Nopember ITS, Sukaluilos, Kampus, Surabaya. Indonesia from the 21 to 22 December 2022. This is the 5th IEEE AGERS conference in Indonesia after successful completion of the first AGERS 2018, second AGERS 2019, and then third AGERS in 2020, and then fourth AGERS in 2021. The first recent development and research trend in the field in geoscience, electronic and remote sensing technology, and the application management of city, land, ocean. The conference will consist of plenary and technical session to cover related topics. In this question, welcoming report by Dr. Arvin Ugro, expert in electronic system geoscience in remote sensing society sector, and Dr. Wahyudi Hasbi, IEEE section. For keynote speakers first, the conference will be delivered by Professor Dr. Muhammad Azhari, Rector of the Institut Teknologi Sepuluh Nopember, Surabaya, and then Dr. Ridwan Jamaluddin, Director General of Mineral and Coal, Ministry of Energy and Natural Resources, Republic of Indonesia. And then the Director of PT PAL, Indonesia, from Professor Dik Mohan, IEEE Senior Member. And then Dr. Wiwin Bindu Pranata from the Institut Teknologi Bandung. And then Dr. Ansar Park from the Director of Korea Indonesia Maritime Marine Technology Cooperation Research Center. And then the fourth keynote speak of the second day of the conference will be delivered by the Institut Teknologi Nasional, and then the Dr. Lalu Muhammad Jalani, Institut Teknologi Sepuluh Nopember, and finally Dr. Takio Ito Nagoya University, Dr. Muhammad Iqbal Habibi, expert of an IT and decision support system. All keynote speaks and entitled speaker will dedicate our inspired to speak related to science, technology, innovation to achieve the sustainable development goals. And then for finale, I would like to ask all of you to attend the existing conference by processing
Okay, so thank you so much, Professor Bangun, for the report. And once again, to all participants, we are really sorry about the technical issues that we just experienced. And moving on to the second agenda, and the second agenda will be a welcoming remarks delivered by the chair of IEEE Indonesia section. We would like to invite the Honorable Dr. Wahyudi Hasbi, who has already joined us also via Zoom. So, hello, Dr. Wahyudi. Hello, Dr. Wahyudi. Can you hear me? Okay. So hello, Dr. Wahyudi.
Yeah, hello. Hello.
Good morning.
Good morning.
Thank you so much for joining us in this very special occasion, which is
Loud and
AGERS.
clear.
Loud and clear, right? Okay, good.
Okay.
Thank you, Pak Budi.
So now it's the time for you to make a welcoming remarks to us. So the next one, Dr. Wahyudi, time is yours.
Thank you. Distinguished guests, colleague, researcher, professional, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Very good morning, a prosperous and warm greetings. First of all, please allow me to greet the Honorable Rector of Institut Teknologi Sepuluh Nopember, Surabaya, Professor Muhammad Asyari, who kindly host the conference today, Dr. Ridwan Jamaluddin, MSc, Director General of Mineral and Coal, Ministry of Energy and Mineral Resources, Republic of Indonesia. IEEE joined Aerospace and Electronic System and Geoscience and Remote Sensing Society Chapter, Dr. Arifin Nugroho, President of Indonesian Society for Remote Sensing or MAPIN, Dr. Agustan, Chair of IEEE Indonesia Section Oceanic Engineering and Technology and Engineering Management Joint Society, Dr. Marina Frederick, General Chair 2022 IEEE Asia-Pacific Conference on Geoscience, Electronic and Remote Sensing Technology, Dr. Agustan, Professor Bangun Mulyo Sukocho, our local organizing committee of this conference, all distinguished keynote speakers from various institutions and countries, Professor Sikmohan, Dr. Hansan Park, Dr. Wiwin, Dr. Takeo Ito, also from Nagoya University, distinguished speakers, committee, all participants, ladies and gentlemen. It's such an honor and pleasure for me to be able to greet you all and give a few words to represent the IEEE Indonesia section at the opening of this conference. On behalf of the IEEE Indonesia section, I would like to express my sincere gratitude and welcome you to the 2022 IEEE Asia Pacific Conference on Geoscience, Electronics and Remote Sensing Technology, sponsored by IEEE Joint Aerospace and Electronic System, Geoscience and Remote Sensing Society Chapter, under cooperation with National Research and Innovation Agency MRIN, Masyarakat Penginderaan Jauh Indonesia, and Institut Teknologi Sepuluh Nopember, Surabaya. 2022 IEEE Asia Pacific Conference on Geoscience, Electronic and Remote Sensing Technology provide a good platform for academic, scholars and practitioners to exchange ideas and discuss about recent development and global research trend in the field of geoscience, electronic and remote sensing technology, with some area of interest such as land, ocean, atmosphere, disaster mitigation, and many more. Distinguished guests, colleagues, researchers, professionals, ladies and gentlemen, space technology changes very rapidly nowadays. Under the name of new space, there is an ongoing revolution in the space sector with the new players, commercial, entrepreneur, businesses, enter a domain traditionally occupied institutional player. We call it all space. For example, the space agency working with large company that exploit the new opportunities opening in front of them. This could include a new service offered through the application of space data, for example, the precision navigation, agriculture surveillance, to Earth environment monitoring, and also to more futuristic opportunities such as space tourism or asteroid mining. And of course, successful entrepreneurs from other sectors, from Richard Branson in the UK or Elon Musk in the US, have entered the space arena, taking risks and challenging the conservation of established old space business model. Remote sensing also has a larger impact on environmental sustainability and climate change. In the recent study of remote sensing for agriculture application in Science Direct studies, the author stated that remote sensing has a capacity to assist the adaptive evolution of agriculture practices in order to face these major challenges, by providing repetitive information on crop status throughout the session of different scale and for different actors. In such so, I believe that the theme of this conference is very relevant in highlighting the development of the remote sensing technology. Distinguished guests, keynote speaker, ladies and gentlemen, IEEE Indonesia as a regional organization unit of IEEE. We are founded here in Indonesia in 1988. And over the past 34 years, we have established and contribute various activities that encourage science and technology for humanity in Indonesia. And together with all volunteers and members and all stakeholders, we have supporting more than 70 high qualified conference every year, including this high qualified IEEE conference. And compared with the previous year, we have increasing of supported international conference by 50%. And not only that, we also hold more than 40 professional, technical, non-technical, and administrative activities every year for all our members. And currently, we have more than 2,500 Indonesian members and more than 80 senior members consisting of professional, industry, academia, and government researchers. We are also supporting 26 technical society. Last night, I just approved one more new chapters, electromagnetic compatibility society chapters in Indonesia. So now totally 27. And we also have 34 university student branches and 9 IEEE student branch chapters. One of the joint chapters, IEEE joint chapter, which is very active, is of course the joint chapter for aerospace and geoscience and remote sensing. Hence, I would like to invite all of you to become the members of the IEEE Indonesia, as well as the Society of IEEE Geoscience and Remote Sensing Society. Not only that, in 2021, we established the cooperation with the Ministry of Education, Culture, Research and Technology program, and also including taking part in the program of Kampus Merdeka and Merdeka Belajar. And also, we are exploring the cooperation with Indonesian industry in various activities, also involving in preparing related government regulation as well. Last few months ago, we already established an MOU with Indonesia Telecommunication and Digital Research Institute to establish the learning, research, and innovation collaboration through publication, empowerment, and education to develop Indonesia leadership, innovation capability, and digital talents. So, ladies and gentlemen, in this occasion, I would like to express my gratitude to all of the committees, all my friends there, starting with Dr. Agustan and Pak Oni and all the members. And all the teams, of course, in ITS who have worked very hard in preparing this high qualified IEEE conference. I'm very aware that putting together a conference of this size is not an easy task. Therefore, I sincerely hope for your cooperation and active participation in all of this conference program. I hope all of you will have enjoyable and valuable experience during this conference. So please share your best knowledge in your area of research and expertise. So please stay active, stay healthy. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, so thank you so much, Dr. Wahyudi, for the welcoming remarks. And following the previous agenda, we will hear a keynote speech and also an opening remarks followed by the representative of IEEE Joint Aerospace and Electronic Systems, also Geoscience and Remote Sensing Society chapter. We would like to invite the Honorable Dr. Arifin Nugroho, who has already also joined us via Zoom. So hello, Dr. Arifin. Can you hear me?
Hello. Yes, of course.
Okay.
Can you hear me?
Yes, it's clear enough.
Yes.
So thank you so much for joining us on AGERS 2022. And after this, you will have time for giving speech and also please to welcome this conference. Okay, are you ready, Dr. Arifin?
Yes, I am.
Yes,
I
okay.
am. Thank
So
you.
the next one, time is yours.
Yes. Good morning or good evening or whatever, because this is supposed to be an international conference and also being organized by Zoom. So let me express this welcoming you by mentioning the following. Bismillahirrahmanirrahim. In the name of Allah, the Merciful and the Compassionate. May peace be with you and may God bless you all. Dear speakers, professionals, researchers, ladies and gentlemen. On behalf of the AEAS and GRSS joint chapter of the IEEE Indonesia section, we have to congratulate the BRAIN, National Research and Innovation Agency of Indonesia, MAPIN, Masyarakat Penginderaan Jarak Jauh or Indonesian Society of Remote Sensing Technology, and last but not least is the IEEE Indonesia section, Dr. Wahyudi, for the collaborations in holding the AGERS 2022, which is being locally organized by Institut Teknologi Sepuluh Nopember Surabaya or ITS. The committee, it seems to me, has exerted its hard effort to running this reputable series of technical conference. This reputable series of technical conference par excellence amid the still difficult pandemic situation in certain part of the world, and yet is still be able to gather quite a number of contributions ranging from general geoscience and hazard modeling, remote sensing and sensor and platform, remote sensing for ocean and meteorology, remote sensing for city management,
recording in progress,
and Internet of Things. In this opportunity, there are 66 paper inputs, and after the review, 38 of which are finally accepted to be the contributors to the present conference. Let us convey our sincere thanks for such excellent contributions of paperworks by the authors and co-authors coming from academic institutions from 7 countries, if I'm not mistaken, India, Malaysia, Iraq, Russia, Thailand, the Philippines, and Indonesia. We should also be grateful for the great support extended by the excellent keynote speakers to make this event more meaningful, which graciously share their topics and its updates and trends. I should mention the following excellent keynote speakers. First, Professor Dr. M. Ashari, Director of Sepuluh Nopember Institut Teknologi Surabaya. Then Dr. Ridwan Jamaluddin, Director of General of Mineral and Coal, Ministry of Energy and Natural Resources, Republic of Indonesia. Sri, Director of PT PAL Indonesia. Number 4, Professor Sif Mohan, IEEE senior member and also from GRSS Gujarat, India. Number 5, Dr. Wiwin Windu Pranata, Institut Teknologi Bandung. Dr. Han San Park, Director of Korea Indonesia Marine Technology Cooperation Research Center. Those are the keynote speakers in the first day of the conference. Then the following are the keynote speakers for the second day. First, Dr. Nani Hendiarti, Marine and Environment Remote Sensing Expert, Deputy Coordinating Minister for Forestry and Environmental Management. Number 2, Dr. Sony Darmawan from Institut Teknologi Nasional. Number 3, Dr. Lalu M. Jailani, Institut Teknologi Sepuluh Nopember. Number 4, Dr. Takio Ito from Nagoya University. And Number 5, Dr. M. Iqbal Habibi, the expert in IT and decision support system from BRIN. Thanks should go to the executive committee under the chairmanship of Dr. Iqbal Habibi and co-chairmanship Mr. Oni Bipin Bintoro MSI MBA, as well as to organizing committee of 10 November Institut of Teknologi Surabaya under the leadership of Professor Bangun Mulyo Sukoyo as a chair and Dr. Lalu M. Jaliani co-chair. Both are from Geomatics Faculty of ITS. Please allow me in this special occasion to also thank MAPIN, Indonesia Society of Remote Sensing, through its chair, Dr. Agustan for excellent arrangement to make this event happening. Now, on behalf of GRS and AAS, Joint Chapter of Indonesia Section of the IEEE, with expecting the blessing from Allah the Almighty, and by expressing Bismillahirrahmanirrahim, I hereby declare the AGERS 2022 opens. May God bless you all. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Okay, well, thank you so much, Dr. Arifin, for the heartwarming opening remarks. And after this, we will have a little break for more or less 10 minutes to prepare the presentation of today's conference. So please, to all participants, enjoy our videos.
G.
Recording stopped.
S.
Is the IEEE
Geoscience
and Remote Sensing Society.
We work to advance science and technology in the field of geoscience and remote sensing. Our mission is to build a community of researchers and practitioners by means of knowledge sharing and scientifically rigorous dissemination of the latest advancement in remote sensing. The members of our society have skills in all aspects of remote sensing.
Digital beam farming,
machine learning methods for robust data fusion,
micro remote sensing,
water quality monitoring and mapping,
micro radiometry and global navigation satellite systems.
There are a lot of different points of view. Sharing the knowledge among the different communities is what makes this society stronger.
GRSS has established 7 technical committees at the moment, and they all cover different technical aspects. The technical committees are really meant for doing the technical outreach to other parts of the research community and industry.
As a society, we want to inform our members and reach different communities via different channels, like for example social media, journals, and especially education. We have 3 series of webinars. GSS has a high school and undergrad student outreach program to engage the next generation of remote sensing professionals.
At the moment, we have more than 60 chapters and 20 student branches all over the world. The chapters are our link with local communities, and they facilitate communication with our members.
IEEE GRSS fully supports distinguished lecture program and also supports for workshops, seminars, and sharpnet programs. Our students are actively engaged in different activities, including competitions.
Our chapter is composed by graduate and undergraduate students. The activities comprise workshops, webinars, lectures, short courses, training, and we have humanitarian activities.
I'm part of the San Francisco Bay Area Joint Chapter. This is a chapter that brings together professionals and those in industry. There are so many geospatial things going on in the Bay Area, and the chapter has been a great opportunity to bring all of those communities together.
All the activities by the societies are supported by our volunteers. We have position for everybody who is willing to help.
I'm a GRSS Young Professional Ambassador. My goal is to empower and motivate young professionals around the world.
I'm a GIS social media ambassador. We post the latest information about GIS every day.
We aim at inspiring technical community to advance remote sensing. Everybody is welcome to join us.
GRSS connected to a lot of interesting people working on a lot of interesting topics.
Society acts as a platform to provide resources and opportunity for us in advancing our career.
I enjoy being part of such a great society with amazing people to create experiences for people to remember.
Being part of GRSS allows me to be a better researcher and professional, improving my skills and knowledge to do a good job. Come and be part of this great family. Ciao!
Welcome back to AGERS 2020. Now, let me introduce you, our moderator in this very special occasion. So today's conference will be led by Diploma Engineer Oni Bintoro MBA as the moderator. And for your information, Mr. Oni itself is currently one of the researchers at BRIN and also a doctoral student at ITS. But before that, let me give you an information. In the afternoon, the technical session will be filled with presentation, and tomorrow, the best presenter and also the best paper for students and general participants will be announced. So straightforward to the moderator, Mr. Oni, time is yours to take over this session.
Thank you, Mbak Putri. Thank you for introduction. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera bagi kita semua. Good morning, good afternoon, and good evening. Ladies and gentlemen, welcome to Asia-Pacific Conference on Geoscience, Electronic, and Remote Sensing Technology 2022. My name is Oni Bintoro. I was assigned by the conference chair, led by Professor Bangun MS Sukoyo, to moderate the discussion. You have already some opening speech by Professor Bangun, Professor Wahyudi Hasbi, and Professor Arifin Nugroho. And now we came into the session for discussion. We have, during our planning program, we have Professor Muhammad Ashari, Director of ITS, Institut Teknologi Sepuluh Nopember, and another speaker is also Dr. Ridwan Jamaluddin, the Director General for Energy and Mining. Also at this time, the Governor of Bangka Belitung. Professor Muhammad Ashari cannot attend at this moment because he have another meeting in Solo, but he gave already his speech 2 days ago. We have actually two conference, OETIC and AGERS by IEEE. So apologize that I can't attend this. And then the second is Dr. Ridwan Jamaluddin, because as a governor, he has I think he was called a meeting by Indonesian president. So we hope that we can reschedule his time for tomorrow. As a result, we changed the program of today. So there will be the first speaker will be Dr. Takio Ito from Nagoya University. He's supposed to give a speech for tomorrow, but we will shortly give a first presenter, and then the second presenter will be Professor Shiv Mohan from India, and we're going to use Zoom. And then the third speaker will be Professor Wiwin from ITB, also from Zoom. And the last speaker will be Professor Hansan Park from Korea. He will be join us 1.5 hours from now. So every speaker will give 30 minutes for their presentation. So it will take 2 hours. And then in the last 1 hour, there will be some question and answer. And there will be some question and answer from here. It's also from Zoom chat or YouTube Live. I will pick some question. I will ask directly to all the speakers. So during the next 2.5 hours will be very lot of scientific knowledge that will be dispersed, and at the same time there will be question and answer. For the first speaker, I will introduce you Professor Dr. Takio Ito from Nagoya University. He is currently an associate professor at Nagoya University in the area of geology and volcanology research. Previously, he attended Nagoya University, California Institute of Technology, and then give some public lecture in Indonesia, in Aceh, ITB, and in UGM. Now, without further ado, I give floor and time to Professor Dr. Takeo Ito from Nagio University. Floor is yours.
Thank you very much for the introduction. I want to share to screen this way. Can you see my screen? Yes. Okay. Can you see the pointer?
Yes. Oh, pointer no. Yes. Pointer no.
Oh, okay. Yeah. So I want to talk about the evaluation of inland seismic potential using the geodetic and the seismic data. My name is Takeo Ito, came from the Nagoya University, and then this co-author is Sato Hiroki. He is my student. So this picture shows my laboratory pictures. So many Indonesians available, 1, 2, 3 people. At first, for introduction, seismic potential by government. Japan government published the seismic potential for each active fault to many faults. So, but this is just only focused on the magnitude 6.8 or over the 6.8. So this one is based on the geologic and the geomorphologic data. So this problem is how to estimate the earthquake potential in traditional method based on the BPT distribution. So this is for one example. We assume to the recurrence time is 3,000 years. Latest activity is 2,500 years ago in case. So this one is blue area. This time from the latest event here now is currently 2,500 years, right? So, and then if we want to know the probability within the 30 years, so its area is blue one. So, and then estimate the probability is blue area divided by the blue and yellow area in PDF, its region. So this is essential estimate method. So this one is just convert to the probability and the latest event. So in this case, we should know the recurrence time at fault and last activity when occurred earthquake. So, actually, damaged earthquake occurred in off-target fault. In traditional method is need the location and the recurrence time and last activity, but usually earthquake occurred is not target fault. So it means that, for example, this one, latest star means that earthquake occurred after 1995. So this star location is almost to the off-target fault. So it means very useful for the geodetic observation can detect the strain because geodetic data is not dependent on the target fault. So our purpose is to assess inland earthquake potential in Japan using the geodetic data and seismic data. So a little bit talk about the Japan tectonic background. So this is bird view. This red line with the coastline on the Japan. So Pacific plate here and Philippine Sea plate here. So this one is Philippine Sea plate subducted under the Japan island, there. And then on the Japan island divided several blocks. This line means the block's boundary, and this one is subduction boundary. So in Japan is very complex tectonic features. So, and then for interpret earthquake, not inland earthquake, interpret earthquake is several studies are available. So using the GPS network. In Japan, we have the GNSS observation. So total is 1,600 GPS sites on the Japan island. So we show the result of GeoNet. And also, Japan have acoustic GPS site on the sea bottom. It means the blue arrows. And okay, so using these data, it converts to the interpret coupling distribution. This is one example of the result of our laboratory. So that means the large back slip. It means the slip deficit rate. So, but this one is just only know the rate of slip deficit. So it means not the probability of the earthquake. So we should need more information. So, but this one the high resolution because this is one where is the high earthquake potential increase. We can know this result. So, and then, this result is based on the block motion model. Block motion model means we explained this one. So, a V means the observed geodetic deformation. We try to divide the three parts. One is a rigid motion. Second one is elastic. It means a coupling effect. And then third one is internal strain of the blocks. We divide the three parts. So formulation is here. The rigid rotation is almost, this one is just rotation. It's not to accumulate the strain or stress. And this second part is, this is generated the earthquake potential because this one is only affect the block boundary and plate interface. And third one is the internal strain. This one is a little bit important because this internal strain means generate small earthquake, so off the fault. So this is result. So observed GPS data is separated into three parts. So one is relative motion along the block interface. Looks like this one, and also we separate the elastic deformation and from the subduction, and elastic deformation from others for including the internal block and the block boundaries also. So usually we use this strike slip. Strike slip means almost to the effect to the inland earthquake. But this one is just only along the active fault. But this result is not solved to the earthquake potential of of the faults. This is just only along the fault. So we want to try to estimate the earthquake potential. So using the GNSS data and the seismic catalog. So GNSS data is converted to the strain rate, and then also convert to the geodetic moment rate. So moment is easier to understand to the earthquake potential. And also, seismic catalog is try to the good and repeated Richter law. We estimate the A and B. So convert to the this geodetic moment rate and Gutenberg-Richter law. So we can calculate the probability of earthquake occurrence. So we use this data is left panel. So after that, so we remove to the rigid motion of the cluster blocks and the interplate coupling, because we want to focus on the inland faults. So in GPS data on the Japan island, it's large effect of the subduction. So we should be removed this effect. So after that, so we can more accurate estimate in the effect of the inland fault, inland earthquake. So we convert to the strain rate. Left-hand side panel shows the strain rate, just only remove the interplate coupling. And then right-hand side panel means the remove the rigid motion of the blocks. So you should be compared with each other. So you can see the more block boundaries, more better see the block boundaries. For example, red line shows red area increase along the blocks. So we use this strain rate. So, and then we already get the strain distribution. So we convert to the geodetic seismic moment rate using this formulation. So this formulation needs H depth. This is the idea of we assumed the one plate. So this plate of deformation observed the GDS data. So, and then this deformed to convert to the seismic moment rate. But we need H. H means the depth of the width of the elastic plate. So this one, H, we use the D90. D90 of the 90% of the earthquake occurrence depth. So, and then beta more important, but this is very difficult to estimate because elastic and beta means the contribution of the elastic part and the inelastic side. So it means that we did not know how much the inelastic deformation. So, but we just assumed the several value. So this we estimate D90 from the seismic activity. This one in Japan case is a little bit to almost to 20 kilometer depth, but some area is more shallow, some area more deep. So we use this heterogeneous distribution for the D90. So it means the plate thickness. So we obtain the result of M0G. So it means the seismic moment rate from the geodetic data. So this is almost a kind of the potential of the earthquake potential, earthquake activity. So, and then next one is we use to the seismic catalog. So currently, now our purpose is the shallow earthquake. So it means that we cut off the effect of the subduction and the deep earthquake is removed. So we use this earthquake selected earthquake catalog. So, as you know, the Gutenberg-Richter law. So vertical axis means a logarithmic scale. So this one is the distribution of the number of the distribution versus the magnitude and the number of the earthquake. So this famous law is A minus B M. So this slope means the B. A means the magnitude at the magnitude 0 to the number of the earthquake. So we use this A value is strongly depend on the number of the earthquake. So it means that depend on the length of the period, right? So it means we use to the this A value from the seismic catalog, but we want to know the activity of the seismic moment from the geodetic. So we try to instead of the A seismic catalog to using the A from the geodetic. So and then B value also used. B value is important of the estimating the seismic characteristics dependency of the magnitude. So at first we should be check the magnitude. So in Japan is a little bit special case because Japan magnitude is the JMA magnitude. So we should be convert to the moment magnitude. So we check some using this formula. So we can use this formula. So it's okay, converting, and then estimation of the completeness, the magnitude. So usually seismic cut of the magnitude means for example, this one, this slope is suddenly changed to the magnitude 3/4. So this area is strongly dependent on the seismic observation network. If sparse, so more this completeness of the cutoff magnitude is more larger. So in Japan case is we have a good seismic network. So completeness is 3.8 around there. So we should be check the completeness of the magnitude. And then we used the GRO. So GRO is usually a little bit not robust. So truncated GRO is more robust method. So we use this one. So A calculated from the geodetic seismic moment rate using this formulation. So this one G already estimated G0, M0G here, and then B value came from the Gutenberg law, and also M max is maximum magnitude. This is assumed. It's assumed. So I'm using this one to N. Using this formulation, is A mean the incorporated here instead of this one. Okay, so this is number of earthquakes. This one is strongly dependent on the location. For example, this red area is Kumamoto earthquake, and then this is many micro earthquakes occurred in the Wakayama of the Wakayama, and then this one is also a large earthquake occurred in the magnitude 8 inland fault. So this is very heterogeneous of the number of the earthquakes. It means the seismic catalog is not uniform. So we should be considered to these heterogeneous of the quality. And then, so this is result from the A value and B value. So A value usually number of the earthquake at the magnitude 0, right? So this is a log scale. And then B value from the seismic catalog is usually, this value is almost 1. But some place is increased, some place is decreased. So after this, for example, Kumamoto area is not, B value is smaller because large earthquake occurred, and then now is a little bit to decrease the small earthquake. So this one A value from the seismic catalog. Oh no, mistake. This value is from the geodetic. Yeah, A value for the GNSS. So we use this formulation. So using the M max and M0G, M max, and the B value is combined to the one equation. So we estimate A value. So this one is estimated to the A value from the GNSS data. So it means that in seismic catalog, it is strongly dependent on the quality, but this one is almost uniform. So I think this one is pure distribution of the seismic activity. And then, so using these distribution is combined, so we estimate to the probability of the earthquake for inland. So like a mesh distribution. So for the government, just only focus on the active fault. Now is like a mesh distribution of the earthquake potential. So, but we should be know, we did not know the recurrence time and also recurrence time and we don't know the recurrence type. So we assume to the Poisson process to the earthquake occurred almost randomly. So, but this one is just only select to the period of the probability period. So, for example, this one is now is earthquake decreasing this probability. So it's important that this area. So T increase this to the more wider. It now is 30 years. If we choose the 100 years, so this area is increased. So it means that this area is the probability. So this one result of the earthquake probability for the earthquake more than 6 magnitude. So highest area is 2 or 3%. It's very highest. Look at this one. So this one is available the medium tectonic lines here. So seismic activity also in largest, and then geodetic data is also large. So, but black dot means that B value is over than 1.5. B value comes from a seismic catalog. This seismic catalog is this one. This method is using the selected area. It chooses the small area. It's so it means the number of earthquakes is very few. So it means sometimes occurred the unstable for the estimate B value. So we removed this area. So this limitation of the B less than 1.5, B value is 1.5. So okay, so this conclusion. We evaluate the earthquake potential in southwest Japan based on the geodetic data and the seismic activity. So this result is covering the of the active fault. It means that officially the government just only focus on the active fault, but this result is covering the all area. So and then it's of course we try to the for Indonesia region. Indonesia region is my student is Rio. So already done the block motion model using the BIG networks. So we estimate the interplate coupling and also inland faults also. So and then Suchi-san from the ITB. So she is a visiting student in Nagoya from the ITB. So she now is trying the estimator ask a potential distribution on the near the Java and our Java area. And also, so now we going project, collaborate with Dr. Chechep and Augustenson and Mudrik. So they are GNSS, Augustin is insert, Mudrik active fault. So our target is several halls, this area. So and then Arif-san. Arif means he is belong to the Nagara University student, my students. So he came from the BIG. Now he is special research student, but next April, so he will be a doctor course student. So his major is insert. So collaborate with these person. We should be evaluate the several faults. After this conference, I will go to the this area. So we make the new GPS sites, several GPS, almost 10 GPS sites to put in there, and then we try to combine the inside data. So thank you very much for the.
Thank you very much, Professor Takeuchi. Please give applause to Professor Dr. Takeuchi. Thank you. So enlighten the presentation, especially you put the increasing the potential earthquake prediction using the Poisson, and what happened there in Japan. You're applying also in Indonesia, and you have already some group of Indonesian researcher, including here is Pak Agustan. I read Pak Agustan is responsibility for INSA. I know Pak Cecep for GNSS and Pak Godek for activity FAO. You have also some student there, and I hope it will also enlarge your network by having a presentation here because
sorry. So there is always a glitch in this type of presentation. Okay. Thank you, Professor Takeuto, for your presentation. It's really enlightening presentation. You mentioned your new propose for including the Poisson process, the probability to increase the predictability of earthquake prediction in the area of Japan, and now it's also applying to Indonesian case. You have already some network of researchers, including Dr. Agustan. Agustan is here. In your presentation, Dr. Agustan responsible for INSAR. I know Pak Agustan is an expert of INSAR. Pak Cecep for GNSS, Pak Mudrik for activity fault, and also you have also some student there, PhD student visiting scholars at Nagoya University, and I hope that we can replicate that after this presentation. Thank you very much for your presentation. Please stay here because there will be the second speaker is from Pak Sif Mohan, and then another speaker Pak Wiwin dan Pak Hansan Pak, and then we will continue with the question and answer. I will ask Professor Sif Mohan, are you already? Professor Sif Mohan. Yes. Oh, you have to close. Yep.
Allow me to.
Yes, Professor Sif Mohan. So I just introduced for 30 seconds about you. I know Professor Sif Mohan is very instrumental into AGERS conference because of his blessing, first AGERS in 2018 can happen. That's in 2000. So Professor Sif Mohan always contribute to our conference. Professor Sif Mohan previously is worked for ISRO and also chair for IEEE in Gujarat. And now is Professor Sif Mohan will give a presentation, and I'll look forward to your presentation for about 30 minutes. Time is yours, Professor Sif Mohan.
You allow me to share the screen.
You can share your presentation, your slide.
Yes, it is disabled. Screen sharing is disabled.
So try again. We give you already the right to share your slide.
Okay.
Yes.
Okay. So good morning. And I will be talking on the remote sensing technology, that how we are using for disaster management with special emphasis to urban disaster, because the urban mostly population is staying in urban, and because density is high in urban areas, so I focused that what we are doing and what we can do with this remote sensing as a tool to help the planners and decision makers so that they can have a better management of urban disasters. So if we look for the kind of disaster, the natural, that means seismic, earthquake, water and the volcanoes, tsunami, mostly coastal cities are influenced. Then because of climate, the high winds, and because of storm or cyclone or tornado, precipitation, then temperature extreme is other important thing, which is now very varying with a very high rate, and erosion, drought, of course not a Darwin, but it influenced the urban population and urban floods. Among these, what I have given in red color is the one which influences more in the urban areas. And now the question is that are we seeing that there is number of increase in disasters? Yes, there are some. One is there's a increase in reporting, improved rather reporting, and population density has gone up. So that's why the large number of casualties. Mostly, if you look, the 64 world's largest city are seismic zone or floodplain. So the risk factor is very high for the cities, and of course, global warming and anthropogenic we are making the effect on these disasters. If we look the remote sensing as a tool, what is available presently is the optical and infrared remote sensing as a tool, whether it's a hyperspectral is not available, but the multispectral and the panchromatic sensor, which are providing a high resolution image in a black and white or a colored multispectral. In the thermal region, we get the temperature of the globe at a different scale. And of course, microwave is used at a time when there is a cloud cover or any other region. And data is available from all these sensors at different scales. So there is a large application of such data for urban disasters. What I am talking about, what we can see from these sensors in the visual region 400 to 700, then the infrared regions, and of course beyond with the thermal and the micro region, some of the applications. So if we see the optical regions, most of the radiation which is reflected from the Earth's surface is being collected at each point, and we get a image of the Earth's surface. Whereas multispectral sensors have the ability to provide much more information, because there we utilize the spectral signature of each object, and we have a better distinction between the various objects, various features on the Earth's surface, and we are able to discriminate with a better ability, of course supported by many of the new algorithms. If we look at the data set, which is from the optical sensors, thermal sensors, thermal sensors, and of course, multispectral sensors. Presently, from Indian region, I can say that we get a resolution of 0.5 meter, 2 kilometer kind of thing, so that we can cover any part of the Earth's surface and repeatedly. Of course, this is not that repeatedly, but you can tilt the camera to see some of the portions repeatedly. So that's the ability. And in the thermal region, the emission in the 8 to 14 micrometer is used for the measurement of the temperature of the Earth's surface, and this temperature is used for some of the application related to urban disasters. So like this, one of the map of the urban, it's extreme, showingly extreme high temperatures in many parts of the country, and the extreme heat is one of the potential problem which leads to many kind of disease, and the government is now warning based on these kind of images, and we have a large number of data set for each city, how the temperature is being varying over a period of time, and we have tools available which people can use directly to them. In the micro region, interest comes, especially during flood. We don't get a clear-cut image from the optical sensor, so we use the micro data, and then we are able to get clear-cut images. And if we are talking of urban floods or urban areas, any disaster, then this is one of the best tools, and which I'm talking little more on this also. Let us see the optical part of the images. High resolution images, there is always a possibility that you get the information how much is built up area and how it is added over the years. And this goes into urban infrastructure or urban database, which is basic requirement for any disaster management for urban cities. So we have about 150 cities, 146 cities, where we have the urban database, not fully, but many of them are in process. They have the information about the size of the family, also in some cases, how much population and what are the areas. So any disaster happens, the layer coming from the remote sensing is overlaid on this, and immediately one gets the idea the loss of the population, loss of the assets, and any other, and the way how to move around the road. For example, this road is above the flood line. So anytime when there is a flood, then this is always at a height, so that there is a continuity of the services available over any of the area in this region. This is Ahmedabad region. So some of these kind of things are done based on the, and these points are estimated using multi-rate data set where the floods are extreme in the season. This is one of the images from our cartoon set Indian satellite, which has detected damage caused in the Nepal region, and this technique generally uses the multi-rate data set. So you should have always a data set of the prior to any disaster. Then this data set after the disaster, you get a good information what are the areas, and this is overlaid on the our database is already available, and we are able to predict the kind of damages which has happened in the cities. In addition to these damages, some of the damages which are caused, which is influencing the urban population, is locust, which are influencing the not only cities, they come in a group and affect the vegetation in that area. So you can see that how green vegetation is turned into non-vegetation by the locust in these regions, and this is all around the main city areas, not in the villages. Then thermal is one of the important sensors which gives us information on where the incidence of fire has happened, and because the temperature is directly related with the fire incidence, so we are able to do it very accurately. And the urban heat is one of the issues which is in Indian region, that most of the cities are having higher temperature than their surrounding, and that is what is called the urban heat island. So many of the cities now covered under this to know, and accordingly the management will take care what to be done. And this elevated temperature leads to many kind of disasters like the air pollution, rainfall, for heat-related illness. That is more important in the crowded cities, and also because of vegetation loss. So some correction has to be done in the city planning. This is one image from the eco-stress has been taken, which shows is that most of the cities are in the high temperature and in the process of becoming the urban heat island. Bigger cities, we have already a database, but the smaller towns are also going in that category. So for handling this, we have to create a urban land use map or geospatial database. This uses a high resolution data set and it has all the information. So about 140 towns, we have this kind of information, detailed information about the buildings, about the other assets, and also about the facilities in that town. So it helps us as soon as there is a disaster or anything happens in city, one is able to use this kind of maps and relates with the many kind of phenomena or relates with the managing the assets, managing the transport in this region or providing the relief in those regions. This is an example of urban. This is done by mostly ISRO and government agencies, and this is the urban sprawl information system where it gives how much is the area during that year. This is available for about 10 years. Every 2 years we have this information. And reference layer, this means that what are the layers you want to add over this. For example, the road, transport, school, everything is available as a reference layer. And one can visualize the data. That means on the map, various features like here I have visualized the boundaries, district boundaries, name of the area or village or city. And one can analyze the data. That means if I have to analyze this city, I can get a data of last 10 or 15 years, whatever is available here, and what is the trend of the temperatures or any other parameter which is related to urban disaster. For example, here I have so many layers available for any city, like all these layers have can be overlaid on the city map. And also we can, this is administrative infrastructure, like I said, road, railway. Background image we can select, and any the other few parameters like the atmospheric parameter or the related parameters for that area. But this is not complete. So this is an example how we can visualize the layers. This is 2 years, this yellow is 1 year, and green is after 5 years, the area, how it is developing, and what are the additional parameters or additional infrastructure requirement to support the disaster management activity that is being planned based on this kind of data set. This is a overlaid the city with the temperature data. Like I said, we have many kind of data layer. So this is, I have just overlaid the temperature. So crowded area, you can see the very high temperature, and it becomes less and less. So one can visualize this also, and then one can analyze what is happening in the for last, this is 2001 to 2022. How this one is not complete still because data analysis is not complete, but up to here we have full data set, and one can relate with the how it is varying time, and this is summer data. And it relates with some of the disease here, which are. when it is when it's cloudy, then we need a high resolution data set like this. It is something around 4-meter resolution. But presently there's no data available at that resolution for the urban floods. So we have some way that we could do it. We can find what are the areas, even with the Sentinel-1, which are likely to flood or flooded using a multi-temporal data set and compare with the previous data set. Here what happens as soon as there is a flooding, so these bright regions will be mixed with this steep pattern because there is an enhancement in the double bound scattering, and they become the very bright image. For example, this is the one street building where scattering or reflection taking place from the building. But from the street, you get some double bounce. When there's a flooding, this becomes a water layer where reflection is fully and it's a very high reflection. So generally there's an enhancement of double bounce effect and you get the image, very bright image in the urban areas. Second advantage is that because of this effect, we are able to see the breach in the canal, because of which there is a flooding in this region, because there was a breach of this canal, and we can see them boundaries very clearly, and we can find that what is the cause of flood and where correction has to be done here, and this is all flooded area. But in the high resolution images, I said it becomes very bright because there is an enhancement of double bounce effect and signal becomes very bright in all the regions, brighter than what it is without water. So this is one example of tsunami. India had the first time the tsunami effect. So SAR was that time and we have used that effectively to know the areas which are influenced by tsunami and these all part and how many days it remained. That was also done during this exercise. The other is during the cyclone. It's very difficult to get the optical images. So all the water-related issues, that means disasters due to water spread in some of the cities or village or in the larger agricultural region, is being mapped using Sentinel-1 SAR data, and accordingly the relief is provided into those areas. And also we are able to see the enhancement in the backscatter even from the smaller town. So it's become easily detectable all these regions from the Sentinel-1 data set. Other use of SAR is in terms of its ability to provide a change in the subsidence, or that is because of the acquisition is at one time, and second time when acquisition is done, there is a subsidence, and because of that there is a change in the range between the sensor and the target, and accordingly there is a change in the phase of the result, which is used in the estimation of the subsidence in the area. This is an example, where we have done subsidence over a large area using LOS data set. And first example from our country that how we will be using this subsidence measurement, and subsequently we did it for a infrastructure also. What are the roads in those areas, coal mines areas, where the subsidence vulnerability is very high or very low. They are detected like this, and roads we are seeing some of the roads are very highly vulnerable because of over exploitation of coal. Here there is coal mines, and because of that, so one can take care of these roads, improving the conditions of these roads. Other important, the coastal, which is now we have to worry about. This study is done by from geophysical research lab. I have taken from there this photograph, and all the we have large number of coastal cities which we have to worry for each country. Our country also large number of cities will take care, and will calculate the subsidence in these and in these regions, or in these regions which are the subsidence. This is the area influence. Area influence means larger is the area, more kind of damages are likely to happen. So one can select, there is a basic database, and from here we can select where we can go ahead in this. Now government efforts are large in our country because of the a lot of casualties, and services like various services are provided by the government organization, and ISRO is related forecast, nowcast, current events, and visualization and ocean applications. So these are the some of the things which you get online and anybody can use in addition to government agency. And there is a real-time live tracking of the cyclone, any anomalous event, there is a live tracking, and one can see that. And mainly used by the disaster management agency. ISRO provides these kind of services. In this service, it is the track of a cyclone, and this is a risk map. Higher the risk, red color, and lower risk is yellow, and much lower is the green color. Yes. So like this risk map are provided to the government agency who implements the disaster management activity at the ground level. And this is a portal, anybody can see Bhuvan portal, this is ISRO's portal. You can get some of the data 2D and 3D, and many applications which are provided here related to disaster, ocean, or open data archive, old data one can take, thematic data or weather data. All these are available free of cost for us. But our national disaster management agency is using such thing fully for the ground activities or ground support. So ISRO provides this kind of support to them, and also some of the international agencies, they are doing the service, some of the areas. So this is National Database for Emergency Management done by the National Disaster Management Agency. They take a lot of data set, and our Prime Minister office is mainly controlling this activity, and so that the information goes to users as early as possible. Users are the district management, district authorities, or those who are doing the groundwork for the various relief measurement or various related issues. So these are some of the forecasts which are available in the national database, and many of the things are, you can just see it, are given near real time kind of thing, like the water level, meteorological data, rain forecast, 5-day forecast. So this is one of the important output for the civilians applications. Thank you, and this is not the end what I have shown. We are going much more than what we have done in the past, because everything is not completed till last man, last person in the country is saved. Thank you very much.
tidal datum. Tidal datum is very important in the delimitation of maritime zones, such as territorial waters and exclusive economic zone. The boundary of those maritime zones is commonly delineated from the lowest astronomical tides. In nautical charting, tidal datum is also important to determine the chart datum, which usually refers to the lowest possible tidal datum. Different datums were used in different countries or places, even though the IHO or the International Hydrographic Organization recommends the lowest astronomical tide for the chart datum. When the charts have to be connected each other, a seamless chart datum is required. Then the tidal datum mapping will help the derivation of the seamless chart datum. Tidal datum is also important during offshore surveys and operations, such as hydrographic surveys, and then the installation of offshore infrastructures, mining, dredging, cable and pipe laying, and so on. And if we classify the tidal datum can be classified into three categories: the high, mean, and low water levels. In the high water level, condition or above the mean sea level. If we talk about the level closest to the MSL, we have here mean low water high water NIP, or MLHWN, and then mean high water NIP, mean highest high water NIP, and so on, until the highest water level possible is the highest astronomical tide, or HAT. And then we have mean sea level, and then as the opposite in the low water level, we may have also mean higher low water NIP, this MHLWN, and so on, until this lowest astronomical tide as the lowest possible astronomical tide condition at that area. So how we can derive these tidal datums? We can, of course, to derive the tidal datum, we should have the tidal data. Where we can get the tidal data? Traditionally, the tidal datum at a single point is derived from the time series or tidal components of water level data at that point at the tidal stations. And then, but with the progress of the satellite technologies, with the help of satellite altimetry data, it is possible also now to have time series of tidal data for the whole world, whole globe, with a certain resolution. Using this data, tidal or water level data can be collected from multiple points along the satellite's track. Therefore, we may have a surface level of tidal datum instead of only point at the coastlines. Since we have the tidal datum as a surface, a seamless start datum or separation model can be developed. Another tool to obtain multi-point data is a hydrodynamic or flow or tide model. Similar to the tidal data from altimetry satellites, the tidal data from the hydrodynamic model can also be used to develop a seamless tidal datum surface. So, what we do at ITB, we do the tide modeling based on altimetry satellite data. And the name of our Indonesian tide model is INATIDE, which is now in version 2C. To develop the model, 11 altimetry satellite missions, as we can see here, are used to have a high spatial and temporal resolutions of water level data in Indonesian waters. And in addition to that, for assimilation, calibration, and also verification process, tidal data from 132 tidal stations in Indonesian waters organized by BIG, Badan Informasi Geospasial, are used for this model. So this is the spatial distribution of the altimetry satellite tracks and tidal stations all over Indonesian waters. We still can see that some areas are not covered by the tidal stations like in the southern part of this Kalimantan, and then also here in Papua, we still have lack of tide gauge observation data. So, however, how we start with the altimetry data? This slide illustrates the steps in altimetry data, pre-processing data. Started with collinear altimetry to estimate the orbital error, and then followed by computing orbital bias to get the corrected time series data of sea surface height, and then finally we got the observation data to have the sea surface height as the time series data. And for tidal station data, the pre-processing steps consist of collecting the data from 132 permanent BIG tidal stations. Then the tidal data are filtered using the shifting, linear trend, as well as the removal of seasonal effect to get this filtered data, the time series data as sea level anomaly has been produced. So the tidal data to get, we do the tidal analysis to get these 10 tidal components. We carried out the analysis using input tidal data from satellites, altimetry, tidal station, as well as some global tide models as complementary for those data. The response method is carried out to provide amplitude and phase of diurnal and semi-diurnal components, whereas harmonic analysis by least square was done to have those parameters in shallow water components. So this is the components that we provide in our model. This is a more detailed explanation about how to derive the diurnal and semi-diurnal tide model. A combination of tidal stations and also satellite altimetry data is used to derive this model. The combination using gridding spline tension method to have well spatially distributed gridded data, then followed by the 2D Gaussian smoothing process to have a smooth fluctuation. And how to get the shallow water tide model? Since the altimetry has problems in shallow water tide models, we use global tide models instead of satellite altimetry in shallow water area, and also assimilated with the tidal station data. The process more or less the same. We use the gridding spline tension and then 2D Gaussian smoothing to get this tidal model for the shallow water. And this is the result of the model of our in our Indonesian waters. This is the examples for M2, K1, and M4 for amplitude and phase. M2 is for semi-diurnal, K1 is for diurnal components, and M4 is for shallow water components. So how good is our model? Then should be validated with the tidal station data. Our inner tides models from amplitude and phase compared with the tidal station amplitude and phase, but we're not doing the amplitude and phase. Instead of that, we are using the cosine and sine argument for comparison to get this absolute value in metric in centimeters. We use this algorithm from Anderson 1995 for the comparison for each tidal component, and for all tidal component, we accumulate this single RMSE. This is the result of the validation along with the validation of 2 other tide models just for comparison. We want to know how good we are between the other global tide model. We are using FAST 2014 and TPXO09. And this validation is based on the comparison with 132 BIG permanent tidal stations. We have here in a tides the result is we have a better results compared to TPX09, but slightly worse if it is compared to the FES 2014. However, with 4 centimeters root mean square error for a tidal model, the result is absolutely acceptable. So in order to have, we just got, we just now have the tidal components, and then in order to get the tidal datums, the first datum to be determined, of course, the mean sea level or mean sea surface. And how to derive this mean sea surface? The derivation of this mean sea surface model is based on exact repeated mission of the satellite altimetry data, and also from geodetic mission. From this slide show us the derivation of mean MSS height as it is referred to WGS 84 ellipsoid from the ERM satellite altimetry data. Two main processes are carried out, the collinear analysis, this is to estimate the average value, and the crossover adjustment to have homogeneous mean sea surface height from the ERM data. And from the geodetic mission satellite altimetry, we combine the data with this ERM data to have a higher spatial and temporal resolutions. So the sea surface height and mean sea surface height from ERM satellites are combined with average GM data to get this mean sea surface height final and gridded. And this is the result of this model. The mean sea surface height has the resolution of 2 minutes by 2 minutes. If we validate the result with the tidal stations, again with 132 permanent tidal stations, compared to other MSS model like CLS or DTU, we have a better results in difference to these tidal stations for this mean sea surface height. So we have just one tidal datum, the mean sea level or mean sea surface height, and let us continue the modeling and mapping of this datum. According to the national law number 4 2011 about geospatial information related to the definition of coastlines in Indonesia, we focus the tidal datums into these 5 classifications. The first one is highest astronomical tides, and also the lowest astronomical tides. These datums are calculated based on 20 years predictions, then predict the highest and lowest possible water during that period of time. That's the highest and lowest astronomical tides. And then for mean high water spring or MHWS and mean low water spring or MLWS, these datums are calculated based on the tidal components from the tidal model as explained it before. The formula is based on the combination of 4 main semi-journal and journal components, M2, S2, K1, and O1. Another one is mean sea level or the mean sea surface. Derivation of this datum has been explained before from the ERM and GM altimetry data. And this is the result of HAT, highest astronomical tide, LAT, MHWS, and MLWS. If we draw we draw it refer to mean sea surface, so this is more or less the variation of tidal datums are between -4 to -4 to 4 meters. Okay, and then also in mean high water spring. So this is the results of the datums when it is referred to WS84. When it is referred to WGS84 at ellipsoid, the maps are relatively similar. Yeah, it is because the value of mean sea surface height or the distance between mean sea surface to the ellipsoid are between minus 30 to 90 meters compared to the tidal datum that varies only minus 3 to 3 meters. And this is the result of HHT, the datums if we refer to GeoID. We use INA GeoID 2020 for the GeoID. The pattern is similar to the result that refers to mean sea surface because it's almost similar, the GeoID and also the mean sea surface. So how good is our datum compared to the datums in the tide gauge? It shows the validation of the resulted tidal datum compared to that 124 tidal stations. As we can see here, the root mean square values of the tidal datums are varies between 9 to 15 centimeters if we include all the stations. But when we remove 8 outlier stations, the results are significantly improved to 8 to 14 centimeters. This is some of what we call outliers tidal station, since it is located in the harbor or in the narrow strait, in the river or estuary or semi-enclosed by. So the altimetry cannot cover the area because it's too narrow, the waters. So that's the results. And how about the challenge and the prospect of tidal datum mapping in Indonesia? In order to improve the tidal datum map, there are some challenges to be faced related to tide stations. It requires a denser stations since it's only about 160 permanent tidal stations, which only about 130 has a long period of observations available compared to the length of the Indonesian coastline, which may reach up to 98,000 kilometers. And also the quality control of the data is also an issue since many errors, misses, blanks, data are found. And then how we do the fixing or the transferring process of the tidal datum to a geodetic datum, geodetic fixing. We tie the datums to geoid or ellipsoid should be done with high accuracy measurements for every tidal stations. And then the tidal data should also be easily accessed by any stakeholder or party to optimize the use of the data. And related to the altimetry satellites, improvement of the processing algorithm still need to be done in order to have higher accuracy water level, as well as other derived products, particularly in the shallow and close water area. Since more and more satellite altimetry have been developed, tidal datum mapping can be done with a higher resolution and accuracy in the future. In the modeling aspects, several available methods of assimilation process between satellite altimetry and tide gauge data should be examined extensively. The stability of the numerical method, shorter period of computational time, and offline or cloud storage of the model results should also be concerned in the near future to optimize the result and the use of tidal datum information. So, and the use of tidal datums are currently growing up and becoming more important. For example, the need of separation model. This is the how we separate the tidal and geodetic datums in order to have a fast and accurate offshore hydrographic survey, particularly in the GNSS tide reduction model. So we don't need to have the tidal station close to the hydrographic survey area. We just use the height from the GNSS for the tide reductions. In nautical charting, the need for seamless chart datum requires tidal datum as a surface, not only at a single point, as it is used now. The seamless chart datum will contribute to the national hydrographic datum, which can be determined by the national authority like Pusidrosal or BIG. Last example, please. Indonesia is currently measuring and mapping its coastline, the BIG. The mapping is required for coastal development planning, reducing the coastal conflict, and also for maritime boundary delineations, not only internationally with our neighboring countries, but also internal boundaries between provinces, between regencies, and so on. So I think that's it. Thank you for your attention. I'm giving back the floor to our chair, Pak Oni. Terima kasih, Pak Oni. Thank you.
Thank you. Thank you very much, Professor Wiwin, for your excellent presentation. Starting with the tidal datum, introduction, some challenge, and some prospect. It's also Indonesian tidal datum. That is the presentation of Professor Wiwin. Professor Wiwin, there will be some question and answers after this at 12 to 12:30. So you need to be there. I know some question. I seen some of the participant already raise hand for questioning, for raising some questions. Professor Wiwin Winupranita, thank you very much for your presentation. And the next speaker will be Professor Hansan Park or Dr. Hansan Park from. Currently, he is co-director of the Korea-Indonesia MTCRC or Marine Technology Cooperation Research Centers. So Professor Hansan Park was graduated from Kyung-hee University in 1994 in the area of geomorphology and geographic information system. And after that, working as principal researcher until today in Korea Institute of Ocean Science and Technology in the area of international cooperation, coastal geomorphology, ICZM, GIS, and LIDAR. Currently, since November 2018, he is the co-director of Korea Indonesia MTCRC. Dr. Hansan Park will elaborate some of his presentation on Korea and Indonesia relationship using ocean satellite. So, Dr. Hansan Park, time is yours.
Yep. Thank you very much for introducing me, Professor Pinto. Yeah. I'm very grateful to have a chance present about Korea-Indonesia Marine Technology Cooperation on Ocean Satellite. And actually, my presentation is not too technical things, but I would like to introduce our cooperation and hope to find some more activity, cooperative activity between two countries. So, so that's why the presentation title is like Korea-Indonesia Marine Technology Cooperation on Ocean Satellite. Starting with, can you see the screen? Okay. Okay, there is many issues in Indonesia, you know. You know better than me. There is many pollution, pollution in ocean, and also oil spill or kind of forest fire and something like. But we should also know, even there is just once accident on the sea, there is so many impact for our lives, and also not only for that, but also kind of economic loss. So this is one of the case, Exxon Valdez oil spill case. And that was just one accident, but there is a $2.5 billion economic loss. And Indonesia is the first largest archipelagic state in the world, and also second longest coastline in the world. So there are just so many, there are so many issues, and also need to manage well for Indonesian water is not easy. Yeah, that is also one of the reasons we have this kind of conference using many technology, including satellite something. So monitoring every day and everywhere, there is one challenge. Yeah, usually, in situ data, in situ survey, we cannot do that like this. Yeah, that is impossible. But there will be some possibility, to use kind of technology. Remote sensing is one key technology, and fortunately, Korea government launched the new satellite last 2020. There is two sensors. Has two sensors. One is for Gushi and one is JAMS. And this satellite is geostationary satellite, not polar orbiting satellite. That means the satellite is placed just one place. There is exactly Malgudara sky. So this satellite can cover whole area of Indonesia waters, territory, and also Korea and Australia Sea. So it is very good chance to have good data to manage well for Indonesia water using our satellite. This is a case of service using this Gushi data. I'm sorry, Gushi is geostationary ocean color imagery, the name of sensor. And the new satellite, we have a second sensor, so we said Gushi 2. Anyway, so there is a 10 data service, including ocean environment monitoring and fishery, and also operational use for the disaster monitoring, and also other application. So not only for the ocean, marine, but also in the land, we can utilize this data for managing Indonesia. So I would like to show some cases for using Gushi data. This is using Gushi 1. Gushi 1 is just only observe Korea Peninsula, so the data is only for the ocean around Korea. So this is about fishing ground information. So we can find out where is good for fisheries. So Indonesia also need to improve more fisheries productivity. So we should know where will be good for new fishing ground or something like. So this satellite image data set, it can apply, can help to find out good fishing grounds. And also green algae and brown algae detection. So this patch for the ground algae is not small one, so big one. So and also this kind of turbid plume. Now we can detect some illegal activity on the sea, including dumping something and also mining, and oil spill detecting and monitoring. And C4 is this will support kind of marine transportation safety and also fire detection and tsunami. So this case is for Japan. So 2011, just at that time there's many impact, so we can find out, we can detect the fire or some kind of sediment distribution and before and after changes, and volcano eruption. So this kind of actual cases can be applied to new satellite Gushi 2. So based on MTCIC's cooperative joint research activity, we prepared some proposal for new project for this new satellite. So that is Ocean Satellite Calibration Validation Station operation. So that was started from 2019. During 3 years joint research, we can make a very nice proposal, and we launched a new project just this year with a $5 million budget and 5 years period. So main project objective and contents is development of utilization system to support marine issue in Indonesia. And also we need to improve the quality of ocean satellite data. So we will conduct a kind of calibration and validation, and also provision of a marine observation equipment and capacity building program. Maybe you has curiosity where will be, what kind of data can be used for Indonesia waters management using this GOSI 2. So actually GOSI 2 has two type of data set. One is for local area mode. That is a focus on actually Korea Peninsula first. Yeah. So 12 slot is allocated for the local area mode, but the other 235 slot for full disk mode is covered whole area for the Indonesia and Australia and Vietnam. Yeah. But the issue is actually for full disk mode, we take one data set in a day. Yeah, local area mode, we take a series of data in a day, so we can utilize more purpose. But the full disk mode is only once the data in a day. So, but important point is that data can cover whole area of Indonesia. You can understand temporal or spatial resolution. So this data is not too good for spatial resolution, but very high temporal resolution. And there will be 11 types of product to be served through this project, and for them will be additionally inspected to improve accuracy and virtual around Indonesia. So this is the actual data set last June. So we calculate the chlorophyll concentration distribution in Indonesia water using GOSI 2 data. And we also reviewed how many data set can be used for our purpose. So right diagram shows up the every month observation condition analysis result, for the slots and Indonesia water. And this data will be used to construct the satellite information utilization system, and also construction of satellite data validation system, and training and joint workshop on satellite-related human resources development. And for this kind of purpose, already we conduct many type of survey for two areas. First one is Makassar area. Now, this survey is for the make a good the data result. Improve data quality using calibration first. So we should find out the good price for the calibration side. So reviewed by the existing data set GOSI 2, and we find out the candidate area. So Makassar Strait is very good for the calibration side. So validation side and calibration validation side. Yeah, so we choose this area, and we collect optical property data for the calibration and validation. And Cirebon area also reviewed for the validation side. Actually, Cirebon area is relatively high turbidity area, so it is not for calibration side. But when we have data and we can use for the validation the data, for example, GOSI 2 just can make a distribution map for the turbidity, and we should also checking the result and increasing the accuracy. So we also need to survey on high turbidity areas. So Cirebon will be the kind of proposed site, and also second survey in Makassar conducted. And we also conduct the kind of a capacity building program. And so first the general lecture class on remote sensing was last August, and also second lecture class on just before 2 weeks before in Jakarta. And we have international workshop with 10 speakers from Korea and Indonesia, and almost 100 participants joined there. So this kind of activity is mainly conducted with KIOST and some company in Korea, and also KOHA, Korea Hydrographic and Oceanographic Agency. But in Indonesia, MTCRC conduct many activity and arrange work. So I would like to just a short introduction about MTCRC, and I hope you can also find some object or some topic or something to find for cooperative activity in the future. So our center history is not only just for several years, already 10 years before started. So we have a kind of joint research with Indonesia researchers in ITB and RIPI or IPB and the other also agency and institution. And through MOU and also IEEE, we established the center 2018. We are actually, many people think this we are kind of a project, but we are not project. We are operational body based on two government agreement. So we said we are intergovernmental joint research center, and conducted by two agencies, KIOST and ITB. So we have two directors for Korean, me, and Indonesia is from ITB, Dr. Ibon Christy Rajawane, and a total 25 staff, including 6 researchers. So that means we conduct our own research and also survey by ourselves, also with our equipment. For that, I would like to introduce some equipment. We already have a small research boat. Of course, research vessels are usually a size with 60 meters or 80 meters more, but that is for the more deep sea and also wider area and main purpose. But there is no coastal areas survey boat, so we designed the survey boat for coastal area first. Even it is not big one, very easy to maintain and operate in coastal area with multi-bay macro sounder and single bay echo sounder and SPP and ADCP, CTD, grab sampler, and also many drones, fixed wing, rotary wing, with spectral sensor and hyperspectral sensors, so we can survey on coastal area and classify some object, and also vehicle, and for numerical model server and computers for training and software. And we have also marine chemistry laboratory to analyze for the microplastic using FTIR and also nutrient O2 analyzer, and for the heavy metal pollution, we also have ICP-MS. And we have a weather gauge, weather station, and also tide gauge station. So using this kind of equipment, and we can conduct many actual survey and research, and we hope have more collaborative activity with the Indonesian researchers. So we have 5 activities, but main is a cooperation platform and joint research and capacity building. So additional 2, that is project implementation or local community support. For the cooperation platform, easy to understand, there is many meeting with ministries and institutions, universities. So we also have a MOU with university in Korea and Indonesia. On Monday, we also MOU with Umpati. Already we have ITB and IPB Bogor and Unhas, so we will have more MOU with more university. And also arrange for the 2 ministers visiting and find out some cooperative topic that was blue carbon, seaweed and smart aquaculture, marine debris, and also a capacity building program. And we support the intergovernmental agency kind of COP26 UNFCCC, and we share the data and the news through the many media, SNS, YouTube, LinkedIn, Instagram. And already I showed you that the joint research, we conduct many kind of joint research topic. That is for the make a proposal actually. So the Ocean Satellite project is one of case of good result of this joint research. And we also have a capacity building program. So already 73 students get the scholarship program for master degree program in ITB, and 8 students study in Korea for the doctorate degree, and also there is many skill training program. During COVID-19, we just conduct online training, but nowadays, we start offline training. So I hope if someone who has interest with our training program, please join us. And local community support with field survey also. And through this kind of activity, we already published many publications for international and also seminar workshop and field survey. This is one of case of a field survey in Bali for support ICRG, Indonesia Coral Reef Garden. So we survey for bathymetry, 3D dimensional bathymetry, and also coastal area. And also follow up the survey using also multispectral sensors and support the Sriwijaya search and rescue activity. And also for the aquaculture, we survey KRN using CTD and drone. So many parameters already surveyed for candidate area for the new farm area, and also the spatial distribution for the farming area. And we have 12 trainings and many meetings. And so many media mentioned about us. It is very good. I hope we keep continue this kind of activity for we find out some topic for our cooperation through the review by Indonesia Ocean Policy and also strategy for the CMMI. So this is that one. Based on the world issues, kind of climate change or sustainable development goal, and Indonesia has many type of many kind of policy, kind of renewable energy or blue carbon, MSP, ocean energy, and remote sensing technology. So it will be linked. It is linked with Indonesia marine issues, kind of logistics and environment and fisheries. So we find out the 4 major topics. One is ocean operation, ocean welfare forecast system. Second is about the blue carbon, including mangrove, seagrass, and coral reef and tidal flood. And the ocean pollution, not only for marine debris, but also kind of seawater pollution. And support of the fishery, we were research about the smart aquaculture. For that, we need many cooperation with the government and also institution and university. So not only for we want to spread our cooperation field with many institution and university. Yeah. Thank you very much for that is all for my presentation. Thank you.
Thank you. Thank you, Professor Hansan Park, for your presentation.
Thank you very much, Professor Hansan Park. Please give one more applause to Professor Hansan Park. Thank you very much, Professor Hansan Park, for your presentation. Professor Hansan Park started his presentation explaining geostationary ocean color imagery. Gochi 1 and Gochi 2, which is fly above Indonesian sky, and it have a very complete satellite view. That I also like to have some collaboration for Indonesian purposes. But then later he also explained some collaboration under that platform. This platform capacity building, including some exchange student. I know some student here like to be in Korea. Korea, your country is very popular today, especially after Netflix. There is also some future collaboration in terms of rencana kelautan Indonesia 2022 and 2027. And I know there will be some questions from floor, from Zoom, and also from YouTube Live. I ask, since we have limited time, I ask some questions. Who's going to ask? Okay, Pak Lalu, Pak Robi, and Professor Agustan that going to ask questions. For first time, Professor Lalu, please raise your question to one of four of the presenter, or you can ask the questions to all four. Professor Lalu.
Okay, thank you very much, Pak Oni. Okay, I have question for three of yours, yeah, Prof. Ito, Prof. Hansan, and also Prof. Mohan. For Prof. Ito, I think it is very interesting presentation, yeah, regarding earthquake from geodetics and also seismology perspective. And we know that some researchers currently struggling to do earthquake forecasting, based on many approach. We know that one team from Hokkaido University and one from National Central University in Taiwan also doing some research using total electron content anomaly on our ionospheric layer. Maybe you have any update related to the earthquake forecasting, because I think we have to know about this one, and we need to have technology for forecasting the earthquakes. And the second one is for Professor Mohan. In India, we heard several times your country facing serious difficulty regarding the heat wave. Maybe any information how the government there deal with the issue, such as the mitigation plan, because the same issue, I think, also facing some country, not only India. And last is for Professor Hansan. My background in my PhD is ocean optics, and I know your satellite, Goci satellite, but our problem in Indonesia waters, we have very lack in situ data, for modeling and also calibrating the data for data from satellite. Maybe do you have some projects regarding the data collection in Java Sea for Java Sea, for calibration and modeling? Okay, thank you very much.
There will be, I will receive more questions from floor, and then after that, I'm going to distribute to all the speakers to answer. So I will invite another speaker from Pak Robi and then Pak Agustan.
Okay.
Thank you for the opportunity, Pak Oni Bintoro. So only one question, especially for Ito Sensei, regarding your slide in the slide number 25, if not mistaken. You mentioned especially for the area 1 and 2. Actually, this is near to Jakarta City. So what happened to that area? So if you can explain, maybe a good news, not a bad news for something. Only that one, Sensei. Thank you. 1 and 2. So what happened?
Yes, for Dr. Takeo Ito and Dr. Hansen Park, I think some of your students is coming from Indonesia. Maybe there are some prospective students that want to join your research. Could you explain more on how they can find more about applying to your group, or is there any scholarship for that? And what do you think the research problem that will be more important for them? Thank you.
Thank you, Mr. Robi. So we have 3 questions for 3 panelists, and I will. So it's already for Professor Takeo, Professor Steve Mohan, and Professor Hansen Park. And there will be one more question later for Professor Wiwin. So now, Professor Takeo, Professor Steve Mohan, and then Hansen Park. Professor Takeo, it's your chance to answer some questions.
So, can you hear me? Okay. So, one question from the Augustine. So, slide 25.
25, yeah.
Can I share the slides?
Yes, you can share.
This right?
Yep.
So where?
Those area was, I think it's close to Jakarta. This
Close
one.
to Jakarta.
This one.
This one?
Yeah. What is the interpretation to?
Oh.
Is it good news or bad news?
Yeah, usually this area is on the plate boundary is a little bit deeper.
Deeper,
right?
yeah, okay.
So deeper means the low resolution typically. So it means the not so large effect, I think. So because its noise in GPS data is a little bit noisy. So and then this area, this more shallow part around there, is also occurred. So at the is that okay? 20 around there. So this effect is available still now. So and then of course viscoelastic response due to this earthquake is, of course, this is viscoelastic response already removed, but so not completely removed. So some effect is remained this area. So I think it's not so important that this deep area. This one is already it's okay.
That's the question, yeah, Pak Augustan, yeah. Yes. That's the question.
This one.
Number 1 and number 2. Oh,
number one, number 2. Ah, this one.
Yes.
In inland halt. For inland halt. Oh, I see. Yeah, this one is important to the be careful. Be careful. Yeah, because it highlights the red means the full coupling ratio. So it means the increase.
Increase pressure.
Yeah, increase. So, but if more detail, so you should be check the GPS site. So take differences to the cross faults. So, but now current result is this 1, 2, 3, 4, 5, 6 area is high seismic potential. And then blue one is low. So in addition, you should be check the INSA data. So this result is not checked to the INSA.
Okay. So you need to check the INSA data to confirm the pulse.
I think so.
And that is the responsibility of Dr. Agustan, since you are the expert of INSA.
And then, what?
Professor Lalu asked about your method of earthquake prediction.
Yeah. So, earthquake prediction method is several methods available. So you mentioned about the GNS Tech also from the Hokkaido University and Taiwan. Yeah. So that one is very short time prediction. Yeah, leading time is 1 or 2 hours advance in the earthquake. So this one, our method is a more longer focus time. So it means not overlap to the method. So our method is more provide to the government or some regional citizen to the prepare for the disaster. So GNS Tech is almost to the alarm, a kind of the alarm of the because leading time is few hours. So it is very important to the sharing the information and the covering each other, right? So I think it's important to both important. And then third one?
No? Follow-up questions. Since you mentioned about this one is like 100 years data you have.
Yeah.
In Indonesia, I think we do not have that.
Yeah.
This one, your presentation is about 100 years data.
Yes, correct.
And in Indonesia, I don't think that we have enough database to get the data, probably in just 20 or 30 years.
Yeah. In our method is need a long time period of the seismic catalog. So in Japan case is over 100 years. So but in Indonesian BMKG seismic catalog around 20 years. So a little bit different is the period of the seismic catalog. So now Suchi-san is from ITB students. Now we combine to the several seismic catalog in Indonesia with BMKG combined with the USGS. But sometimes overlapped, so it should be removed to the overlap the seismic catalog, and then is carefully check the quality of the cut of the magnitude. So and then already modify the method to from this one. So now she currently working on the upgraded our method. So now is waiting for the has result. Sorry. So I think it's better aware too.
Thank you, Professor Ito. So next time, Suchi-san
should
present into the next AGES 2023. Thank you, Professor Ito. Thank you. Professor Lalu, is that all the answers to the questions, Pak Agustan? Yes, thank you. Thank you, Professor Takito, for your presentation. So next is Professor Shiv Mohan.
Yes.
The next answer will be Professor Mohan. The question was raised from Professor Lalu on what happened on heat wave in India. I know in your presentation about urban heat index, if I'm not mistaken, and
Yes.
how
You were
to
asking about the management of the heat waves, what we do, isn't it? What you was asking. Hello.
yes, how Indian
We
government
manage it with a number of action plan. The first indication comes from the Indian meteorological condition, that what are the cities or administrative boundaries states which are likely to have heat waves, or not likely, are in the process of heat wave. So in each state, the number of departments we have to cater to the need of the people, need of the department. For example, the first is public awareness, that the red alert will be there for the heat wave conditions, and there will be safety guards for the people, and you will get SMS and radio and television everywhere there will be. And what people should do as an individual, that is one immediately response. Second goes to the medical, that what are the treatment, as such they are trained in advance for the heat wave conditions and readiness for that, and emergency services are available during that time. You just click on that condition, but that emergency services are not for all India at the moment, but many states it is there. The heat wave, wherever heat wave alert is there. Third is information goes to education department. So if there's a need to close the schools during that conditions, they close the school for that period of time, and with a special what you call the order. Then the other department like animal husbandry to handle with that kind of cattle, they are supported by the visitors for various kind of services what they can be provided. So thus there are a number of similarly the transport department, especially the government transport, they have to be continued or they have to be closed for that period. So these kind of conditions are there. But by and large, this is more of a public-oriented service. That means public is being addressed, and government departments are doing duty so that any issue comes during that period, they can handle it carefully. That's how we are doing this. And in Ahmedabad, I'm saying, since 2013, we are getting the red alert whenever there is a heat wave. And there will be SMS that what we should do during that period. So that's the way we are handling at the moment.
Thank you, Professor Mohan. Thank you. Thank you for your answer and your participation into 5th AGERS 2022. Thank you very much for your participation.
Okay.
And
nice.
And next will be Professor Hansan Park. Even though I think I forgot to answer question from Robbie about the exchange program. And after this, I will ask also Professor Takito to answer on question of Pak Robbie on participation, exchange program or student study in your country. Hansen Park, question of Pak Lalu on the quality of ocean color.
Yep. Thank you for question. For me, first question is from Professor Lalu about is there any possibility or plan for the survey in Java area for validation the satellite or numerical model data. Yes, we also clearly understand when we apply to, when we're using kind of remote sensing data and also numerical model data, and we need to validate. Of course, for the validate, we also need to kind of calibration. So for that, actually, our project also designed for that to improve the quality of ocean satellite data by institute calibration and validation activity. So for that, we have a plan to survey, joint survey, or more additional survey for the calibration and validation. So there is a two type of understand the difference with the calibration and validation. So calibration data, we need to very high quality of institute survey the data to make to correct important value in the data set. But the validation is a different purpose. So after the calibration the data, and we apply some area, and if we have many, just how many we can survey, it will be very helpful to validate our data set. So maybe there is two chances. First one is to join our calibration validation survey. Second one is to make a specific application system. We also need to kind of institute survey. So you can join for this project with the two activity. And we also want to share all of the data, survey the data with the Indonesian researchers, whoever want to use it. That will be answer for the your question. And for the Robbie, to join our capacity program or exchange program for students who are researchers. Yeah, we are often for that. Yeah, so maybe next year we also send a kind of request letter to each university or agency who has MOU signed with us. So that's why we want to spread our cooperation with many universities and institutions. So ITS, maybe, So we also.
So it says not yet sent.
Yeah, not yet. Yeah. So I hope we can have a MOU as soon as possible, and then we send we send official letter for the kind of. Opportunity for studying in Indonesia and also studying in Korea, or kind of training program with all of MOU signed agencies and bodies. Yeah. So first one is we need to communication for to make a cooperative background or basis, and then it will be open to you all. Yeah.
Thank you, Professor Hansan Park from MCTRC.
Yeah.
Thank you.
And if you don't mind, may I ask to? Well, please, and you can answer first, and then I would like to ask to Professor Wiwin.
Wiwin, you ask to Professor.
Wiwin.
Because you will be the last presenter to answer Pak Robi. You ask for Pak Wiwin.
Yes. Many. Yeah, worldwide issue. One of our worldwide issues is climate change, and also sea level rising is one of the phenomena by the climate change increase. Yeah, but I saw the many reports from Indonesia government about how much rise sea level. But when we collect some data, you already mentioned that there is one challenge for the tidal station. We need geodetic fixing. Yeah, if there is the datum benchmark level is different with there is some noise or some error. It measures a different sea level rising rate. So I would like your opinion about this. The sea level rising rate is correct, or we need fixing for the geodetic materials first. Yeah, how much serious or is it reliable for the report for the sea level rising rate in Indonesia? That is my question.
Thank you, Professor Hansan Park. So, Professor Wiwin, you have your questions, and also I know it's not
easy one, it's difficult question. How serious is the sea level rising? Using the correct tidal datum, which need to be fixed, has the good indicator. Professor Wiwin.
Okay, thank you, Pak Oni. Thank you, Pak Dr. Hansan for the questions. Yeah, certainly we did this geodetic fixing to tie our datums or this sea level rise data and so on to one fixing, one permanent or fixed datum like geoid or ellipsoid. Because if we refer the sea level rise to only to a benchmark on a land, maybe there are some changes in the height of this land itself by land subsidence or uplifting. So it's not because of the sea level rise, but it's maybe because of the land subsidence. So it will be mixed. But if we tie the sea level into fixed geodetic datums like ellipsoids or geoid, then it would be very much. It will be fixed. Then we can say that this is sea level rise or sea level sink, something like that. But that's a bit difficult to do the geodetic fixing. I mean, if we do the only tidal level to from the tide station to benchmark, we need only by water pass measurements. But if we want to do the geodetic fixing, then we should do the GPS measurements, for example, or even gravity measurements if we want to have the refer the tidal datums or the sea level to geoid. I think that's Pak Oni and Dr. Hansan.
Okay, thank you, Professor Wiwin. But you confirm that this sea level rising is really a phenomenon. Thank you. Professor Wiwin, thank you very much for your answer and also your participation. There is one question left from Mr. Robi. The question is already answered for exchange program to Korea, but then now it's for Japan. Professor Takeo, you're going to answer, but including you need to have some, you will be here representing the other presenter to have your closing statement. Answer this closing statement, and then you closing statement, and then we finish with this session. Professor Takeo.
In Japan case, it traveled to the student in Japan scholarship. So scholarship is important to the living in the Japan. So Japan government provides two types of the scholarship. So one is embassy recommendation. So maybe you can take a test, and then through the pass, you can get the ticket to the scholarship. So this is the one way. The another one is JICA provided also scholarship. Do you know JICA? Yeah. So it is more specific research. So for example, so earthquake or some hazard, something else. So this one is changed to the every year, or several years. This year is focused on the another IT. Another year is focused on the medicine, something else. So this is timing. This is very important timing of the some background of the some Japan government recommendation. This is two types, and then another one is private money. This is private money. So, but very difficult to living in Japan. Another one is university recommendation is available. But this one is very limited to the person. So maybe few people, less than 10 people in the all Nagoya University. So our university have several faculty, over 10 faculty. So it's difficult usually. So I think better to, and then in my laboratory, now is 2 persons from the Indonesia. One is a JICA recommendation. Another one is embassy recommendation. So maybe it's, and then previous students also embassy recommendation. So I think better to, at first you should take a test to the embassy. After that, you can go to the Japan, it's possible. This is very important. And then tests for the enrollment in Nagoya University is important to the English skills, communication. So I think better to learn the English. And then after visiting the university, so you can take a class in Japanese class and some basic of the mathematics, something else. So we are covering to the some basic skills. It's okay, but it's difficult to cover to the money, living cost. Thank you very much.
Thank you. Thank you, Professor Takuito, on how to get into exchange program or to study in Japanese university. 2 models, one using JICA, one is using embassy. That's the answers. Thank you very much, Professor Takuito. And after this, we're going to have a group picture of presenters. So I asked Professor Wiwin and Professor Siv Mohan to open their pictures, video, so we can have a group picture. And in the meantime, I will ask also closing speech from Professor Hansan Park.
Actually, I also have a presentation 2 days before meeting for IEEE. And at that time, I mentioned the importance of science and technology and development, kind of human resources. Yeah. So this IEERS conference also focus on kind of regional resilience for the all of right. And so I hope we can improve our human resources more than and it will be also realized by good cooperative activity with many countries in the world. Yeah, so as director of Korea-Indonesia Marine Technology Cooperation Center, I hope also we have a good cooperation activity and we will do our best. Yeah. Thank you.
Thank you. Thank you very much, Professor Hansan Park, for your answer and your participation. We will have a group picture. First, with only the speakers already done. Okay, Pak Wiwin, Professor Siv Mohan, smile. Thank you. And now it's for all speakers. All participants. All participants, we will have also group picture. Udah difoto semua? We need to take picture for all participants. Picturing all participants. Icon until 15. Pak Robi udah. We need to document it all 100.
Okay, thank you very much. For this session, we have to thank all the speakers, Professor Wiwit, Professor Siv Mohan, Professor Takito, Professor Hansan Park. Thank you very much for your presentation, and thank you very much for all the committee. It's also for participants in this session. After this, half hour from now, we will start our session participation for AGERS. There will be 38 papers going to be presented during today and tomorrow. So we have to thank all of you. Thank you very much. I hope we can have a successful AGERS 2022 and AGERS next year, AGERS 2023. Thank you very much and see you around. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Terima kasih.
Well, thank you so much, Mr. Oni, for leading the conference, and what a very great and also an outstanding conference that we had before. And ladies and gentlemen, we will have a lunch break for within an hour for preparing the next technical session. And as a reminder, again, the technical session will be filled with presentation, and tomorrow the best presenter and also the best paper for students and also general participant will be announced. And after this, the committee will divide all participants into 2 different groups on breakout rooms. And last but not least, thank you so much for having me. I'll see you again when I see you. Have a good day, and wassalamualaikum warahmatullahi wabarakatuh.